Before beginning this protocol, students must fill out the worksheet provided on the last page of this document. This will allow students to calculate the appropriate volume of reagents to mix in the creation of a master cocktail. The purpose of a cocktail is to mix all the common reagents in a multi-sample procedure to avoid excess pipetting and potential errors. In this example of Protocol 2A, 4 students are amplifying the actinin 3 gene from all 4 of their DNA samples. This information is filled out on the left-hand side of the worksheet. On the right-hand side, students use the equations to determine the number of tubes needed and the multiplier for reagent volumes. In addition to the 4 DNA samples, a negative control sample is always included. Therefore, 5 tubes are needed for the PCR reaction. In the creation of the cocktail, pipetting error is accounted for by adding another sample. Therefore, the multiplier for this group is 6. Each row of Table 1 represents a common reagent used in all the samples undergoing a PCR reaction. The multiplier is filled out in all rows of the multiplier column of Table 1. Moving across each row, the volume indicated per reaction is multiplied by the multiplier. (12.5 times 6 equals 75 microliters of red tack added to the cocktail. 11.5 times 6 equals 69 microliters of water added to the cocktail. 0.5 times 6 equals 3 microliters of each of the forward and reverse primer added to the cocktail. Finally, the sum of these volumes should be equal to the product of the final row. 75 plus 69 plus 3 plus 3 equals 150 microliters of total volume in the cocktail. This amount matches 25 times 6. Table 2 is used as a guide for labeling of the PCR samples. As indicated by the equations, this group will be using 5 tubes. The class must collectively number the PCR samples to not confuse samples amongst the groups. In this example, these students have been assigned samples numbered 5 through 9. The sample names are filled out in the second column, and the primers used for each sample are filled out in the last 2 columns. In this example, the forward primer is actinin 3F, and the reverse primer is actinin 3R. The same primers are used for all samples. The common reagents provided are molecular biology water, a forward primer, which you should be sure to check for the marking of PCR to ensure that you are using the appropriate concentration. A reverse primer, and red tack ready mix. The red tack will need to be thawed prior to use, but once thawed, keep the solution on ice to prevent enzyme degradation. Next, prepare the cocktail by using the volumes and reagents indicated on the worksheet. Obtain a new tube and label it as the cocktail. When creating a cocktail, it is best to start with the largest volumes. Though red tack is the largest volume, the solution should be kept on ice as long as possible, so instead the water is added first. When adding each of the reagents, be sure to use the appropriate micropipetter for the volume being added. Next, the primers are added. It is best to pipette small volumes directly into larger volumes to avoid loss of the reagent. Finally, add the red tack and immediately return the stock to ice. Mix the solution and centrifuge all cocktail tubes created by all groups in the class together. Press and hold the short button to do a brief spin.